Hey, assalamu alaikum, everybody. How's everybody doing? Come on, louder. I need some excitement here. Awesome. So it's gonna be fun events. Okay. Quiet. It's gonna be fun events. There will be a lot of good stuff on black holes. I know I have gotten a lot of feedback from people that we should talk about black holes. It's very exciting to everybody, including myself. We will have some quizzes, trivias, some prizes as well. So be ready with your answer. And after the talk is done, we have our friends from astronomy, Austin Astronomy Society, who are coming here to help us with the telescopes. So we will see and try to see if we can see anything through the telescopes. Otherwise, we will talk about different types of telescopes that we have today. So everybody excited? Awesome. All right, so I want to play a quick, one scene from a movie, Interstellar. And I'll tell you the reason why I'm playing that. So let's watch this clip from the movie Interstellar. So this is a giant black hole. And the reason I wanted to show this clip, because Interstellar is one of the very few movies where they actually have used the physics equation to generate this image of a black hole. And so this is the movie. So they actually use Kip Thorne. He's a Nobel laureate in physics. I met him a few years back. He acted as a consultant, and I think one of the producers of the movie also, to provide all the equations needed in the computer to generate actual image of the black hole. So what you see, that black hole in the movie, is very close to the real black hole that exists around. And so I wanted to bring this up so that at least you have a glimpse of how a black hole looks like. So let's go in. Let's talk a little bit more about black hole. So what is a black hole? So very simple definition of a black hole is it's an object. It could be a region or an area where gravity is so strong that nothing, even the light, cannot escape. I'll talk a little bit more. So let's take the Earth as an example. So we know Earth has a certain mass, etc., but there is something called escape velocity on Earth. Basically, that's the speed that you need to fly away from Earth and never come back. So you want to get away from the gravity of the Earth, you need around 11.2 kilometers per second. That's the speed you need. So that's what's happening on Earth. We need certain speed to get out of the gravity of the Earth. Now let's move on. Now let's do something. Let's add more mass to the Earth. Assume we are doing a giant experiment and we add more mass to the Earth and keep the same size. And as you can see, when the when you add more mass to the Earth, it becomes more and more dense. When it becomes more and more dense, the gravity pull becomes stronger, right? So you need more speed, higher speed to get out, right? So the escape velocity goes up. And so what happens when you add 822 times the mass of the Earth? Anybody wants to take a wild shot? We'll get to it. No, no. Yeah, you raise your hand. No, I'll give one more chance and we'll move on. We have more quizzes inside. Yeah, you raise. Oh, no, no. Just somebody say it will become a black hole. Who said that? Oh, you said, okay. So that's the right answer. It will become a black hole. Say again? Well, it will become as dense as a black hole. So mass of black hole could be any size. Okay? So a round of applause for him, and he gets the first prize today. What's your name? Imad. Imad gets the first one. Thanks. Next. So escape velocity becomes the same as the speed of light if you make the mass of the Earth 822 times. Let's move on. So, question, can anybody tell me quickly? First raise your hand, then I'll pick up. What's the speed of light? You raise your hand first. You got almost close. Just I want the exact number. It could be kilometer per second or it could be miles per second. You raise your hand. Yeah. All right, we'll give it. But it's, if you go to the next one, it's 186,282. So let's give it to him. He gave the first try. And so round of applause for him, please. So if you look at it, it's around 299,000, close to 300,000 kilometer per second, or 186,000 miles per second. So our moon is around 300,000 kilometers away from us. So light takes 1 second to start from the Earth and reach to the moon. So that's how fast it is. So it is really fast. So if you add 822 times more mass, the Earth will become a black hole. Let's move on. And this is assuming the size remains the same, right? Size could become smaller or remains the same. Sun can become a black hole. So black hole doesn't really depend on what kind of material or object or whatever it is. As long as it is so dense that the gravity becomes so strong that the escape velocity is equal or more than the speed of light. So if you make the sun, which is very big, and if you squeeze it to 3-kilometer radius, it will become a black hole. So that's an amazing part. So this is a more general question, but why does it matter the speed of light as the escape velocity? Anybody from more adults? Anybody from sister side, brother side? Anybody wants to talk about that? Okay, go ahead. Yeah, but why is it important with reference to black hole, right? Or in general, there is something very unique about the speed of light in the whole universe. Anybody? Yeah, I think I'll give you, yeah, go ahead. No, speed of light remains constant. It doesn't change. Yeah. Okay, you're close. So basically, nothing in the universe can travel faster than the speed of light. So just quite a little bit. So the reason the speed of light is very unique, that nothing in the universe can travel faster than the speed of light in vacuum. What it really means is that if you fall into black hole, there is nothing in the world, in the universe you can do to get out of the black hole. And this is one object in the whole universe where you can try all your best, you can never get out. You can use infinite energy also. You can never get out of the black hole. So that is the important key. Najmul bhai, let's give prize to him. Yeah, yeah. All right, let's move on. So let's look at the structure of a black hole. And people are always confused what it is. I mean, it is dark, it is black. But what really it is? Is it an object? Is it what's going on? So black hole is one of the simplest objects in the universe. And the reason it is simple is because everything of the black hole has been squeezed to the center. So this is called singularity. It's right in the middle of a black hole. It's a point of infinite density. It's a point where all the physical laws break down. Nobody knows what's going on there. Event horizon is a region around a black hole where if you go inside, you can never come out. If you're outside, you can maybe fly by if you have enough speed. But once you're inside the event horizon, there is nothing you can do in the world other than pray, to get out of the event horizon. So let's take a look at some astronauts here. So this guy is basically showing that as long as he's outside and he has sufficient speed, he can get out. But but once he goes inside the black hole, he can never get out. And very interesting thing is that if our sun becomes a black hole today, so if the sun radius becomes smaller to just 3 kilometers, we won't even know. The only thing we will know is that there will be no light during the day. It will become dark. But from the point of view of the orbit of the Earth, it will just go around like the way it is going today. There will be no disruptions to any of the orbit. We will keep Q&A towards the end. So I know you guys have few questions. Okay. We'll talk about that. We'll go there. So just, wait a bit. Let's keep moving. So, okay, this is the question. Do black holes, what kind of surface the black holes are made of? I don't know. Okay, I'll give you a chance. Yeah? Did you say it is hard? Okay, what's your? Hey, are you Googling? No, nobody will Google. I will move away. Yeah. Correct. But what's the surface made of, right? I'll give you a chance. Yeah. No. Anybody wants to take a? No. Anything? Just good. Yeah. What's your question? What's your? Oh, you forgot. No. You guys are. Please don't Google. Just give me an answer fairly, and I'll take. Anybody around? Anybody wants to take a shot? Yeah. Yeah. You. Yeah. No, you? Yeah, correct answer. A round of applause for him. So, black hole event horizon is nothing. There is no surface. So, if you are an astronaut, you happen to fall through event horizon, you will not even know you passed through it. There is no surface. Everything around it has been squeezed to a single point, and nobody knows what's going on there. All the theory of relativity, quantum mechanics, they all break down at this point of time. They just go haywire. And so this is a region in space-time, and which has no surface. Okay, I'll take questions, but I would suggest to keep some questions at the end. Yeah, go ahead. One more question. Yeah, that's a higher level topic, the virtual particles and all. So there is no surface. It's very strange, right? And a lot of time, people will just pass through. They don't know that now they cannot even go back because they have crossed the event horizon. Let's move on. All right, so this is more real image of a black hole. So as you can see in the previous slide, we talk about accretion disk. Basically, what's happening is a lot of material is falling in. And when it's falling in, it collides with each other. It becomes hot and becomes hot gas. And it starts glowing because it reaches hundreds of millions of degree Fahrenheit. And it starts glowing. And that's one of the ways we can actually see the black holes. Otherwise, black holes are dark. You cannot see. You can see it indirectly because of the accretion disk, which is falling into it. This event horizon boundary is basically the boundary we just talked about. Once you go inside this boundary, you can never come back. Singularity we just talked about is at the center of a black hole, and it has infinite density. This is the relativistic jet. So this is basically these ionized gases and matter which get ejected out. It includes gamma rays and others. They get ejected out almost close to the speed of light. And this is also another indirect way to be able to detect black holes. Otherwise, you cannot see the black hole. Next. How do you see a black hole when it is black? All right, I'll give you, yeah. Yeah. No. I'll give a new person a chance, yeah. Like where does the light come from? Yeah, it has one of the relative. What's the two things? Yes. I will give it to him. He gave both the answers. So both. So that's what you see here. There is also another way is by looking at how stars around the black holes are moving, and we'll talk about it a little bit. But right now, two major signs that you can detect black holes is by the gas that is falling in and by the relativistic jets. All right, let's move on. All right, so this is the first image of a black hole ever taken. So this was, can we be a little quieter here? Thanks. So this was taken through radio telescopes, and a telescope called Event Horizon Radio Telescope. So what they did is that they have radio telescopes around the world, and they combined the images of the telescope from all parts of the world, and they joined together and they formed this image of a black hole. So they took two pictures of two different types of black hole. This black hole is located at the center of our galaxy, Milky Way, and it's a supermassive black hole. We'll talk about that a little bit later. Yes, yeah, exactly, yeah. I was asking you to wait for this slide. And so next, name any other galaxy other than Milky Way. I actually forgot who answered just now. I'm trying to get a new person. Did you answer it? Okay, go ahead. Andromeda. All right, round of applause for him. Come on. Can we get him? Yeah. What's your name? Was it? Suleiman. Yeah, Suleiman, this guy. All right, be ready with your answer and no Google. Have you removed the phone? Move the phone aside. All right, let's keep moving. So this black hole is the picture I just talked about. It's at the center of our Milky Way. We are somewhere here. We are somewhere towards the middle of the disk of the Milky Way. Black hole, this supermassive black hole is over here. In fact, most of the galaxies that we have found have supermassive black hole at the center. We are trying to figure out why the galaxy's center has this supermassive black hole. And since this supermassive black hole is huge, it has 44 million kilometer diameter. Basically, if you bring this black hole to our solar system, it will cover the orbit of the Mercury as well. It is so huge. It's big. It's about 4.3 million times more mass than the sun. And it is so massive, it takes up around 14% of total mass of the galaxy. So our Milky Way has around 100 to 400 billion stars. 14% of that mass is just taken by this black hole, supermassive black hole at the center of the Milky Way. So it's humongous, it's huge. And we have taken pictures of, I'll show us a small animation We have taken pictures of stars moving around this black hole. Let's move to the next one. Yeah, so this is, just one second. So this is a partly images combined together and partly simulation where it is going to fly through the Milky Way. So we are as if like you are flying from the Earth and going towards the center, and it will reach up to the point where you have this black hole. And it will show what's happening there. So let's watch it. So it's getting closer to the center. So just pause a little bit. So one thing I will also say, so you guys know about Sagittarius constellation. Everybody knows about it. How many people know about Sagittarius constellation? So this black hole is near one of the stars. Like, it's not near the star. Like, if you look through it all the way to the center of the galaxy, that's where the black hole is. So there's a name of this black hole, and they have used the word Sagittarius. Let's keep moving. Awesome. A star. So these are the stars, and this is the actual image combined together. And these are the stars going around the black hole. So we cannot see black hole, but we can see the stars going around. So this is the event horizon, and you can see accretion disk is forming. So this material is falling in and is forming the accretion disk we just talked about. Awesome. So it's called Sagittarius A star, and this is the closest supermassive black hole we have that we know of. There's another one that we have imaged is in a galaxy called M87, and they were imaged around the same time. Let's move to the next. Oh, you want to take a picture? Okay. Which picture? There are lots of pictures. Okay. Just pause it here. So this is most likely a simulation. This one. The stars that we saw just before this, they were the actual images combined together. Go ahead. All right, so next question. Who predicted the existence of anybody from the ladies' sister side upstairs? Anybody wants to take a chance? Who predicted the black holes? Let's just wait if there's somebody upstairs. Nobody wants to take a chance? No, wrong. All right, correct answer. Albert Einstein actually first predicted. So let's give it to him, Najmal bhai. What's your name? What's your name? Ibrahim, please. Okay. So go next. So actually, you cannot. Quieter, please. Quiet. Shh. So you cannot use Newtonian physics in close to black holes because the gravity is extreme. You can only use Mr. Einstein's general theory of relativity. So he predicted, but he did not name it. Name came later in 1967 when people started figuring out more about what black hole is because they had not seen it. And so they came up with a term called black hole. Can we be, front rows, can we be quieter? Shh. Can we be quieter? So this term was coined in 1967 by some of the scientists, and that's where it comes from. Next. All right, so this is another interesting black hole. So this is called Cygnus X1. Is near. It's not supermassive black hole. It's a stellar black hole. Basically, it was formed out of a single star. It emits lot of X-rays. So the relativistic jet that we talked about, right? It mostly consists of X-rays here. And it was discovered in 1967. I have a very nice simulation of this. We have not seen this, but we have seen the star. So what's happening is that it's eating up this star. So you guys can see this is, the star is made up of gas, right? Mostly hydrogen. And it is sucking in this gas. Guys, is sucking in this gas inside it. And through indirect means, we have figured out that there's a black hole inside. Let's play the simulation.
It was thought this system hosted a black hole 15 times the mass of the Sun. The black hole feeds from the wind of a giant star that is slightly more massive. New observations show the black hole is 20% further away from Earth than we originally thought, placing it over 7,000 light years away from us. This also means the black hole is much more massive than we thought, weighing in at 21 times the mass of the Sun.
This is how it is eating up the
star
star.
Is 22 times the size of the Sun. They orbit each other every 5.6 days. The wind of the supergiant star absorbs radio waves from the high-speed jets that are powered by the black hole. Understanding this and factoring it into our calculations allowed us to improve the distance and hence the mass measurement. For such a massive black hole to exist, the star from which it formed must have lost less mass in winds over its lifetime than we expected. Studying black holes like Cygnus X1 can tell us about the lives and deaths.
So you can see this material is falling in. It's in blue color, but as it gets nearer, it becomes red and yellow because it's heating up even more. And it's heating up and it's glowing. And the black hole is right here and is shooting or emitting these relativistic jets. These are mostly X-ray waves, electromagnetic waves. And so this is what is going on. It's not very far. It's 7,000 light years away. And we have studied quite a bit this black hole.
Stars in the universe.
All right, let's keep moving. So how are black holes formed? Let's take a look quickly at the stage. I have so many hands raised. Are you going to tell me how the black holes are formed? Or, oh, you are. Okay. Was it? When the star dies. Good, good. I mean, there's no gift for this, though. I mean, you're trying your best. Everybody, who else?
When a star runs out of fuel, it turns into a black hole.
Awesome. That's very, very good. Actually, that's pretty close. That's also very close. It turns into a supernova. What else? Also hypernova. Anybody? Yeah. Yeah, star gets supernova. Or what? It's pretty big, pretty high. Oh, yes, please. I think they can form that process. That's one of the ways. No, actually, that is right. So there's a type of black hole. Mostly are formed by colliding two large stars or two black holes together. Go ahead. Star goes supernova. Awesome, awesome. Great answers. Let's take a look at stage by stage. So there's a massive star. So first of all, star has to be massive. If it is as big as sun, it will not form a black hole. Does anybody know what will sun become? Yeah. Awesome. I think let's give it to him. What's your name? Arad, round of applause. Come on. Okay, now who can tell me what happens after it becomes supergiant to the sun? Yes. No. You have no. No, the sun, not the sun. Our sun will not. So for the supernova, you need a massive star. Yeah. It will become it's closer, but not neutron star. Yes, that's the correct answer. So it will turn into a brown dwarf or maybe white dwarf, but it will turn into a special category of that star. So round of applause for him. Maybe Najmul bhai, let's give it one more. No, that person at the back. What's your name? Not him, no, the one who's sitting next to the door. If you don't want, that's fine too. Oh, it's okay then. All right, so let's okay. First condition, shh, everybody. First condition, it has to be very big, much bigger than the sun, like at least 5 to 20 times. The next, so what's happening inside a sun? We all know, right? The sun is mostly hydrogen, and hydrogen is turning into helium, and that is what is releasing the energy through nuclear fusion. It's a fuel, exactly, you're right. So hydrogen acts as a fuel, and what will happen after millions of years, hundreds of millions of years, it runs out of hydrogen. And what will happen the star collapses. And it collapses so violently that it becomes more and more massive. If you go to the next, so it explodes. And the core of this supernova becomes black hole. Now, this is just one example, but the stars die in different forms, even if they are as massive. Some don't become supernova, some are hypernova. There are some kilonova formed. But this is just one example I'm giving how a stellar black hole is formed. And this is a very simple process. There is nothing special about black hole forming. The star has to be massive. It should run out of fuel. It will collapse, and then it will explode with a supernova or hypernova, but the center part will become even more dense, and it will become black hole. So let's go to, there's a nice video clip on this. Yeah, this one.
Supermassive stars weigh 100 times more than our sun.
So this is a very big star.
Gravity. When one of these stars dies, it sets off the biggest explosion in the universe. A hypernova. This is the birth of a black hole. In 1 second, it blasts out 100 times more energy than our sun will produce over its entire.
So this is a hypernova or a supernova, and you can see such a violent explosion this star goes through.
And 2 jets of energy hurtling through the universe at the speed of light. These jets are called gamma ray bursts.
So it forms these jets. We talked about the relativistic jets. So these are the jets. It's not, play again. I think move a little bit back. Yeah, play. Yeah, just play. So I think this clip got cut a little bit early, but at this point when the jets are forming, that's when the black holes are forming inside at the core of this exploding star. So let's keep moving. All right, so there are different types of black holes. There is a stellar black hole we talked about. That's formed from that star in the last slide that we saw. It's the most common type. Then there is an intermediate mass black holes. So these are formed by the merger of other black holes. I think somebody was mentioning about merging of black holes together. Correct. It's called IMBH in short. Then there is a supermassive black hole that's at the center of the galaxies. It is very big. We just talked about it. It's 1 million to 10 more mass than the sun. And it's formed mostly during the, we are still studying. We are still figuring it out, how it is formed. You guys might have heard about the telescope, James Webb Space Telescope. How many people have heard about James Webb Space Telescope? So this is it is a very powerful telescope, and it's making really breakthrough studies in the early part of the universe. And they are using that to study these, how they were formed early in the universe. And then there are primordial black holes. these are hypothetical. Nobody has seen them. They are probably formed in the first few seconds of a Big Bang, after the Big Bang, even before the stars were formed. And we really don't know how they were formed. People are trying to figure out, and it's probably due to fluctuations that happened during the very first few seconds of the universe. And so these are the 4 types of black holes that we have formed. So I will have a Q&A, and Najmul bhai, how many quizzes, how many more quizzes are we left with? Okay, so I'll ask questions also. Let's do a Q&A session quickly. Probably let's give around 10 minutes for the Q&A. After that, we will go outside. I'm not sure if some of my friends are there. I don't think Sky has gotten any better. Yeah, so what we will do is that if we can't see any object, we will talk about different types of telescopes for you to learn. So we have a group of volunteers, my friends and fellow members of the Austin Astronomy Society who have come to help us out. And they have set up all types of telescopes. So we will go after the Q&A is done to over there. Let's do a Q&A for 10 minutes. Yeah, go ahead. For what? So the question is, can we use black holes for galactic transportation, like wormholes kind of thing? I think nobody knows. I mean, there is no established science to that. We in fact don't know what's going on inside a black hole, right? The singularity, nobody knows. Those are very hypothetical studies, but there is nothing concrete, no experimental evidence, obviously. Yeah, next question. So the question is, can primordial black hole, now if you can go one slide back, can they be supermassive? It's possible. I mean, I don't think there's an established study on this, but these, maybe they end up becoming a supermassive black holes later on. But I don't think there is very established, scientific studies that's going on. Yeah. So as long as you are outside the event horizon, and if you have enough energy, you can not get sucked in. So it doesn't really matter how far. So remember I mentioned about if the sun becomes a black hole today, we will not even feel it. Like this Earth will go on the way it's going. Saturn, Mercury, every planet will be orbiting the way they are. The only difference will be that there will not be any morning tomorrow. There will not be any day, right? It will become dark. But in terms of movement of bodies around the sun, nothing will be impacted. Yeah. No, he is. Oh, okay, go ahead. Your question. I don't think so. Yeah, go ahead. So question is a good question. Why there is a supermassive black hole? I don't think we have very established studies on that. One of the reasons probably is that as you get closer and closer, these objects, they get close to each other, they combine together. And if they're massive, that leads to them becoming even more denser. And probably it's building up over time because universe is almost 13.8 billion years old, right? So like over the period of time, which is a very long time, maybe they're combining and more black holes are forming by combining together. But as far as I know, I think that's what they are figuring it out also. Okay, yeah. I think it's purely based on the studies, mostly. I mean, because nobody has seen them. I think there are some mathematical. Yeah, exactly. I think there's some. Say again. No, so in cosmology, actually, we have a friend from the cosmology who is doing his PhD. Maybe I think he can take a shot at that question. But I don't think. Do you want to take a shot? I mean. 1 second. So his question is like, what are the established studies that tells us about the primordial black holes? Say again? In the right. No established studies yet. So actually, $400 million. So that's when the cosmic background. Right. So no really established studies. Very hypothetical, but I think they have some established equations to tell them that if there is enough fluctuation in the early part of the universe, it can lead to black holes. So I'll take few questions upstairs. Yeah. What is the James Webb Space Telescope? Where? Oh, it's outside. No. It's about 1 million kilometer away from the Earth. So it's in space right now. I wish we could have James Webb outside. I would love to see it, like, if possible. Any other? Yes, go ahead. Can you repeat?
What happens if you get sucked into a black hole?
We talked about it. Inai, can you go few? Yeah, let me give a little bit more detail on that. I'll talk about that. So no, go back. So when you get sucked in, so again it also depends on is it a supermassive black hole or it's a small black hole. If it's a supermassive black hole, most of the time you will not even feel anything. You will just keep entering and you will feel like normal. Suppose, assuming you are in spacesuit, you will just keep going inside. But if the black hole is smaller in size, the gravity changes so fast between your feet and your head, you get something called spaghettization. Spaghettify. Your body gets like extended and becomes like noodles, like spaghetti. And the reason is because your bottom part, gravity is maybe millions of times stronger than on what is in your head. Like, so just a small distance, there is such a big difference of gravity. So you get spaghettified, and then once you reach this singularity, nobody knows what's going on because our all equations break down at this point of time. Quantum mechanics break down, relativity, theory of relativity, general theory of relativity break down, and nobody knows what's going on. Yeah? Not 0.0, Lagrange point. So around the Earth, actually around any object, there are points where the Earth gravity and Sun's gravity cancel out. So for example, take an example. If you are between Earth and the Sun, there is a point where the gravity from the Earth and the gravity from the Sun is equal. So you don't feel getting pulled from either side. So that's called Lagrange point. And there are few Lagrange points around the Earth. So what they have done, they have put the James Webb on the other Lagrange point, which is on the other side of the Earth. And the reason they put it on the other side of the Earth, they want to protect the telescope from the sun rays. So that's why if you notice the picture of a James Webb, I think we have a slide. Ina, if you keep going down, I have some backup slides. Let me just quickly show since there is an interest on James Webb. Keep going. Yes, stop here. So this is the James Webb, right? So this is a shield that is always facing the sun. And the reason they have made this shield because they want to keep this away from the sun rays because they want to keep it super cool. So this James Webb is running at around 7 Kelvin. They have to maintain 7 Kelvin temperature because it only works in infrared. If it goes higher, then the infrared that's coming from the instrument themselves will blanket out the infrared coming from the galaxies. So it is hypersensitive, and they have formed this. This is as big as a tennis court, if I'm not wrong. and basically it protects from there, and it's at Lagrange point 2, I think L2 Lagrange point. I'll take one more question. Yeah, I'll take one more question. I think we have some friends sitting, waiting outside. I'll take from somebody I've not. Anybody upstairs? Nobody? Okay, all right, with a cap. No, these are mirrors, but they are covered in gold. They have a very thin layer of gold because gold has some unique properties to absorb the light and reflect the light back. So that's why they look like gold. All right, so what we will do, we will all move out. So before that, I want to have a round of applause for our volunteers from the Austin Astronomy Society. Let's give a round of applause to my friends. And also from volunteers from ICBC. Also, my daughter Inaya, she's helping out with the slides and all of that stuff. So let's just go outside and have a look at some of the telescopes outside. Thanks.
We are going outside. There will be a complete darkness. There's no light. So be careful. Please be careful because there's no light. Without light, we can see the stars much better. Okay, inshallah. Please line up according to the line they have. There will be some guidance there. Inshallah.